nice and detailed presentation. Our second speaker is Dr. Lekhendra Tripathee. Sorry, Dr. Saab, if I cannot pronounce it correctly. So,
Yeah.
Dr. Saab is working as a research associate professor in State Key Laboratory of Cryosphere Science, Northwest Institute of Eco Environment and Resources. He has great contribution with atmospheric pollution and cryospheric change. So the topic of the presentation is air pollution in South Asia and its impact on cryosphere and water quality in Himalaya Tibetan Plateau. So that's why I will request you please finish your presentation within 20 minutes. Thank you very much.
So thank you very much, Doctor. So can you see my slides I have shared?
Yes, it's okay.
Yeah, it's fine.
Yes.
So I will shortly start with my presentation today, and I would like to thank the organizing committee for this opportunity to present my work in this international seminar here. So I would also like to take this platform to present my topic on air pollution in the South Asian region and its impacts on the cryosphere, climate, and water quality in the Himalayan Tibetan Plateau region. So I would like to start with some problem here. So these are the contents from my presentation today. I will talk something about the research background and aims, and then our observation networks in the Himalayas and Tibetan Plateau and the Third Pole region, and the impacts on the glaciers from the air pollution are like black carbon and dust, like our previous speakers also talked about it in. But however, I will talk about this in details in my presentation and some future prospects. So I will shortly start with the research background and aims. So South Asia. So we know that South Asia is one of the most populated and polluted regions in the world nowadays. And you can see this green areas is known as the IGP plains. So also known as Indo-Gangetic plains, which is the most populated and polluted regions over the South Asia. So the pollutants emerging from these areas during the dry period could form a brown haze, which is also known as the atmospheric brown clouds. You can see in this satellite image, and this could be transported to the Himalayas and Tibetan Plateau, and also can be deposited to the glaciers. So the measures, what are the sources of these pollutants over this region are the industries, traffic, garbage burning, brick kilns, crop residue burning, and cooking. So we know the sources, but the very little is known about the relative roles in contributing to air pollution over this region. So the issues are the Himalayas and Tibetan Plateau region are considered as a pristine area with limited pollution. However, in the recent days, we have evidence that the transport of pollutants to those regions, rapid warming and glacier melting, and also this is the research gap zone due to the difficulty in the sampling and field works and everything going on, and the complex topography of this region. So here you can see the pollutants emerging. This is the South Asia, and from the ocean, this pollution could be transported by westerlies and South Asian monsoon to the Himalayas, and finally taken back to the Himalayas, glaciers, and ecosystem through dry and wet depositions. So also these pollutions not only deposit in the Himalayas, but by the glacier valley wind system, it can be transported further back to crossing the Himalayas to the Tibetan Plateau. So the Himalayan Tibetan Plateau, also known as the Third Pole, has a very important role in the water system and everything, and climate systems over the region. And the topography and high altitude of the Himalayan Tibetan Plateau here plays a significant role in formation of Asian monsoon climate and global circulation of the atmosphere. Due to the climate change, there is a changes in hydrology, cryosphere, and biosphere everywhere. It can change. And what's the role of changing climate? Because the climate forcing effect is due to the increasing industrial emission from South Asia, biomass burning for cooking, and from the natural biomass burning from the forest fires and economic power has raised this region as the focus of public scientific interest. So you can see here the large amount of AOT, black carbon aerosols. This is the black carbon aerosols over this region, which are covered like a haze over the region especially during the dry periods. So the previous research has also talked about the glaciers shrinking over the Himalayas and Tibetan Plateau region. Glacier has shrunk by its length and size both, and also the impact of black carbon should be considered before air transport, and deposition of black carbon also should be considered in the current days due to the further glacier shrinkage and climate change. So also here you can see the East Rongsborg Glacier in the northern side of the Mount Everest in 1921 and 2008. There is a drastic change in melting and disappearance of the many snow and ice sheets over these decades. So why we focus on this reason is the changes in Asia's water tower will affect the life of billions of people downstream, living downstream. And you can see that these are the glacier region is glaciated regions. The climate change and the impact of the pollution could reduce the glaciers. And the Himalayas and Tibetan Plateau itself contains with a total area of about 1 lakh kilometer square of glacier mass area. So for this, our aim was to to feature and characterize and know the amount of what is the characteristics of these pollutants from the South Asia and their transport mechanism, how they transport to the Himalayas and even to the Tibetan Plateau, and what's their impact on these regions glaciers and waters and how the whole ecosystems. So for that, our basic design was monitoring and sampling, then laboratory analysis, and also modeling and assessment. This is work done by a whole team of group. So today I will focus on the major pollutants which can affect the environmental system of the glaciers and the cryosphere over the region, like carbonaceous aerosol. I'll talk about some organic carbon, black carbon, and water-soluble organic carbon in the atmosphere, and the levels and impacts on the cryosphere about the light-absorbing impurities such as black carbon and dust. And another pollutant I would focus today is about the particulate mercury, which is particulate mercury in the atmospheric particles, mercury in precipitation samples, dry and wet deposition fluxes, and mercury in the cryosphere. So why I want to focus on carbonaceous aerosols means that it is mainly produced from incomplete combustion of fossil fuels and biomass burning. And it can strongly absorb solar radiation at visible wavelengths, causing the warm effect. And it can decrease the albedo of the glacier surface and accelerate the glacier melting. And it has a direct and indirect impact on the climate, water resources, agriculture, and human health, and so on. So you can see here the impact of atmospheric pollutants in glacier melt is like light absorbing impurities, and light absorbing aerosols, when it deposited, becomes light absorbing impurities and can reduce the albedo of the glacier surface and increase the glacier melt. And then it's for the enrichment processes, and again the process is cycle. So we want to know the spatial and temporal loading sources and its impact on the glaciers through different observation and modeling studies. So to know about the historical trend, you can see that since the 1960s, after the Industrial Revolution, it has drastic change in black carbon concentrations. It has been shown from the lake sediments and others. So in the South Asia also, since 1960, it has a drastic increase, and in also the world, the EC flux has been increasing. The BC burden has increased by 2.5 folds from the background period to the industrial times. So why I will focus mercury is because it is a global contaminant, toxic contaminant bioaccumulation. It can bioaccumulate and biomagnify and long range transport it, and it has a long atmospheric residence time, and in the atmosphere, and it can be transported and deposited to the glaciers, and which could impact to the river water system and the glacier fed rivers over the region. So this is the global emission of mercury, and you can see that the China and India too are the most highest producer of these toxic pollutants over the environment in the region, over the world, and it has a significant effects on the human health due to the mercury cycling from the atmosphere to the release from the industries to the atmosphere to the ecosystems. So I will go to our observation networks. So this is our observation network known as Atmospheric Pollution and Cryospheric Change, which is led by Professor Sichang Khan. And we have two transits in Nepal side and many other observation stations in Tibetan Plateau and surroundings, like in Pakistan, Mardan, Hunza, and Karachi. And our colleagues, Dr. Chaman Gul, is taking in charge of these Pakistan observation sites. So these are some of the pictures from our sites, but however, I am focused on this Nepal side region currently for this network. So why we focus on the climate is because one of our colleagues did this work, and she found that the pollutants from the South Asia, she found an event on 2009-316 that the high AOD concentration, and it was at that time the pollutants was transported from the South Asia to the remote central Tibetan Plateau site, Namswa. You can easily see that this is that pollution transport to the region. So I will show you the spatial distribution of organic black carbon and organic carbon in the aerosols particles in the atmosphere. So you can see that these regions from the cities and Indo-Gangetic Plain and the cities has the very high concentrations, like in Karachi, in Lumbini, and in Kathmandu has the highest concentration. And when it go up to the remote sites, it keeps on decreasing. So it's in the decreasing trend of the black carbon aerosols. So going on to the seasonality, in the dry period, especially during the winter and pre-monsoon and post-monsoon period, has the highest concentration, and during the winter has the lowest concentration due to dilution effect. In both sites, I have chosen two sites here, one in IGP and one is another polluted sites. Both has the decreasing size. So this is due to you can see that we did one work, and during the pre-monsoon season, lots of haze over this region has a high aerosol optical depth, which can also, this is during the dry period, has a immense haze, and it serves as a blanket of pollutants to the Himalayan region. It covers like a black haze and a brown haze, and it can increase the concentration of all these pollutants over this region. So if we talk about the seasonal spatial distribution or seasonality of water-soluble brown carbon, also it is like that, similar from the IGP to the Tibetan Plateau, it has a decreasing concentration, and from the urban to remote site, it has a decreasing concentrations. And similar seasonal trend, like in monsoon, the lower concentration than in other dry periods. So also these during dry periods, winter, pre-monsoon, and post-monsoon, you can see the loss of fire, which is observed from the MODIS data, and it can reach the sampling sites through the air circulation pattern, and which could also impact to the concentrations of these pollutants over this region. So I will go to the now mercury in the aerosol particles, so and its dry deposition flux. We did some research from Indian side in Kanpur and in Lumbini, another IGP site in Kathmandu. It has a very high concentration. However, the other remote site has a very low concentrations of these pollutants, these higher mercury. And also the fluxes are in the similar trend, like the deposition flux is also the similar. You can see that in India and in the Kathmandu, it has a higher deposition flux of these particulate mercury. So I will show you the result from my work, and it has also the mercury has a similar seasonal patterns like particulate mercury, like the black carbon, and also it has a good correlation with the total carbon in the aerosol particles. So we mean to say that this maybe have some connection with mercury and the black carbon concentrations over this region. So maybe it has a similar sources and formation processes. So for the wet deposition, like we collected some rainwater from different sites from the Himalayas, and we found that the high concentration, also found the high concentration in the urban sites and low concentration in the remote sites, and higher fluxes in Kathmandu and Lhasa and in Nepal Himalaya side than in the Tibetan Plateau, because most of the pollutants could not cross the Himalayas and to the Tibetan Plateau, and mostly they are deposited in the southern side in the Nepal Himalayas. So we have a high concentration as well as the deposition flux over the southern side of the Himalayas. So seasonal characteristics is similar to as the black carbon and particulate mercury, higher in non-monsoon than in monsoon seasons. And during the monsoon, mostly the wind pattern is from Bay of Bengal and East Asia monsoon. And however, in non-monsoon is from the westerlies wind prevail, which brings most of the pollutants to the Himalayas and gets deposited. So now I would talk these pollutants impacts on the glaciers and how they impact. So light absorbing impurities like black carbon and dust, I was talking, those aerosol, black carbon aerosol, when transported and deposited in the glacier, you can see it changes the color of the glacier, and it's little brown or dark black, and it can also decrease. This can also decrease the albedo and accelerates the glacier melting. And this is one of our colleagues did this work and found that during the fresh snow, BC has a more role for the radiative forcing and glacier melt than the dust region. So contribution of these light absorbing impurities and glacier melt in the northern boundary, we went to the field work for this research in 2013-14 and collected the glacier snow samples, and we found that the BC has 22.3% impact on the glacier melting, and the dust has a slightly less impact than the BC glacier. So after this role of black carbon, mercury is also a very important toxic metals which could impact the health of the whole ecosystem. So you can see that our colleagues collected the sample from these areas, from the glaciers to the river waters, and they found that the highest Ag concentration in the river in Lohugo region, Lohugo Glacier in the northern Tibetan Plateau region, northern boundary of Tibetan Plateau, and highest Ag concentration in Yulung Mountain, which is in the southeast Tibetan Plateau. And the highest percentage of dissolved mercury was found in snow samples, and the lowest percentage of dissolved mercury was found in the river samples. So this is very important findings that to know about the regional mercury transport to the aquatic ecosystem and rivers over the Himalayan Tibetan Plateau regions. So previous studies from the Emmanuel said that in the future, due to the climate change and glacier melt, the runoff of the water level and runoff in these areas would be increased. And for this reason, also known as third pole, there is a need for integrated approaches addressing the significant pollution's impact on the cryosphere and environment in the Himalayan Tibetan Plateau region. And also it can serve as a fundamental scientific basis for the regional environmental protection and policy making also for this region. So I will go to the summary. So now integrating our research results, we can say that atmospheric pollutants are sourced from biomass and fossil fuel burning and dust emissions from the South Asian region. And they peak during the dry period, especially during winter and pre-monsoon. And they are accumulated in the foothills of the southern side of the Himalayas, and the episodic cross to the Himalayas to the Tibetan Plateau through the southwest North Valley are advicted over the Himalayas and Tibetan Plateau. And the carbonaceous aerosols, so that black carbon could have warm effects on the climate and transported and deposited on the glacier surface can enhance the glacier melting. And melting glaciers are important sources releasing the pollutants. Like those transported pollutants like mercury pops to the glaciers can be taken back to the water ecosystems by major rivers into the downstream ecosystems, and it can impact on the human and the ecosystem health of the people and living downstream, and impact on the river water system in the region. So these are our findings, and there are a lot more to do in this aspect. This is just the starting, and we need to do the long-term spatial and temporal monitoring analysis, learning about the remote sensing and modeling work, historical reconstruction of these pollutants in the environment, isotopic fingerprints to find out their particular sources over the region, and definitely finally our focus will be on the society, what's these impacts on the climate and water resources, and impacts on the societal health and impacts, and the water quality of the region, and integrating the results for policy formulation is a need in the future. And recommendation for reducing air pollution over the region will be done, should be done in the future from long-term monitoring and evaluation and the research over this region, in this critical region. So with this, I would like to thank you all for listening to my talk. And this here is the cover page of our book on water quality in the third pole, the roles of climate change and human activities. We edited this book this year. It has been published online. Thank you all for your kind attention to my talk.
Thank you very much, sir, for your nice presentation, and surely I will go through your book. Our next presentation